In this particular unit, we're going to be working with properties of exponents, and you should have really learned a certain amount of properties of exponents in Algebra 1. So for section 6.1, which if you pay attention to the units, we are actually going to couple this with chapter 7. So we will come back to the remainder of chapter 6 at a later time and point and cover the remainder of this unit. But chapter 7 has to do with the properties of exponents, and 6.1 in this case is a great review of what you learned in Algebra 1. Now, a couple things that you kind of need to know before you head into the properties of exponents. We need to be familiar with, the base, and then the power, or what we would call the exponent, because not always will it be a numerical power, but sometimes we'll be dealing with exponents that are variables in later units. So the base can be numerical or a variable, and we will learn how to deal with each of these at a different time. However, the way we want to start is by just a quick review of the properties of exponents. And understanding how to do each of these properties is very important. The names themselves are good to know, but I'm more concerned with your ability to recognize how to and when to use these within the framework of a problem. So I'm going to review each of these properties, some in more detail than others, and point out a handful of things that you probably want to be careful not to do, and some things that you need to do. So let's just take a quick review of these. I'll start with the first one, and we notice it's called the product of power properties, and this is the one that most students are most familiar with because it gives you two exponent problems that have the same base and they're being multiplied to each other. So let's just take a look at how that would work. So if we're looking at this, I could have a problem that is numerical in nature, and what do we mean by this is that it has a numerical base. So say we have 2 to the third power times 2 to the fourth power. And so what we have here is we have two bases that are exactly the same. That being the case, we can take this problem and consolidate it or simplify it into a problem that has the exact same base. And if we look at our product of powers property, what it tells us is if they do have the same base, we can add the exponents. So we can say 3 plus 4. And so in this case, I'll have 2 to the 7th power. Now, since this is numerical in nature, we're going to want you to finish this problem. Although I do not expect you to know 2 to the 7th power, you can then simply use your calculator. So we can do 2, and then we can hit the little caret symbol, which is going to give us the exponent, and then we can hit 7, which is going to give us the number 128. So this problem would be finished with 128. Now, let's look at this a little closer and see why it actually works. This time I'm going to do it with an algebraic expression. And so if I use x as a variable to the third power times x to the fourth power, what we technically get here is x to the third plus the fourth, which is going to be x to the 7th, exactly like what we had before with the numerical base of 2. Yet in this case we don't know what x is equal to, so we cannot get a numerical final answer for this. So our final answer is actually x to the 7th. But what I want to show you is why and how this works. What x to the third is technically telling us is that we have 3 x values being multiplied together. And then of course x to the fourth is 4 x values being multiplied together. And then of course we were multiplying those values together, so I now have 1, 2, 3, 4, 5, 6, and 7 x variables here. So that is x to the 7th power, which is the same thing that I would have gotten using my product of power property. So whichever way you feel most comfortable with. Now, what I'm going to tell you here, the difference between Algebra 1 and Algebra 2 in many cases is that a lot of times in Algebra 1 you can take the x variables and line them all out like I did in the blue ink and come up with an answer that way. In Algebra 2, however, many of our problems are so lengthy that you will not have enough space nor time to list everything out this way, so you would be better served using the properties and knowing when you need to add them and so forth. Now let's take a look at something else that we must keep in mind. Notice on both of these examples the base was the same, but if I were to have x to the third times y to the fourth, I would not be able to simplify that any farther because I have an x and a y as my base, and since those values are not the same, they cannot go any farther, so you cannot add those two exponents together. So it's very important that you recognize the base. Let's take a look at a couple of others. So if you look at the second one, the power of a power property, what you can see here very simply is that we could take a power of a power. So if I take 2x squared and I raise it to the third power, I'm actually going to multiply those two values, so that gives me x to the sixth. And of course, if I have more than one value in the parentheses, so if I had 2x squared to the third power, this is the power of a product property. So now I have to raise each one of these to the third power, and so this is going to be 2 times 3. So 2 to the third is 8, and then that again is x to the 6th. So you can see there's same concept for each of those, except you would have to apply the power outside the parentheses to everything in the parentheses. Now let me make one point extremely clear here, and I'll go back to my other page to demonstrate this. We can have multiple values in here that can be raised to a certain property, and of course this too would be applied to every part in here, which is going to make this 2 squared times x, and then of course that's 2 times 2 because we're raising a power to a power, and then that's y to the second power, and then that is z, and of course 3 raised to the second power is going to be multiplication, so I'm going to end up with 4x to the fourth, y squared, z to the sixth, and of course if I do not put any operation between my variables and of course my coefficient, it is an understood multiplication problem. However, if some of you recall from factoring, if I had a situation like this, I cannot supply the exponent to both parts because of this addition. So it's very important that you do not make this mistake with the power of a product property or the power of a power property. Very important that you recognize that this is actually x plus 2 times x plus 2, which is x squared plus 4x plus 4, which is not x squared plus 4. So very important that you recognize the difference when there's an addition or subtraction operation between the parts in the parentheses, whereas in the previous problem up here there was multiplication, or it was just understood as multiplication, and then you can distribute that power to everything inside the parentheses. So that is an extremely important part of understanding the difference of when to apply that property and when not to. So keep that in mind. Now if we go back to the property list, we see a negative exponent property, and so you can see that if I had a value like x to the negative 2, that's going to be the same thing as 1 over x squared. This is extremely important because all of your answers must be written without a negative exponent. And let me give you another version of this. if we go back to our sheet again here, if we take 1 over x to the negative 2, we can reverse that as well, and that's going to be a positive x squared. So it can go either way. So very important that you understand that difference as well. Now, the zero exponent property, this is something that you should always pay attention to. Anything that is raised to the 0 power always equals 1. So keep that in mind. If you see something being raised to the 0 power, you can quickly exchange that for the number 1, and that can make your properties much easier. Lastly, if we look at the negative exponent property, we can do the same thing as we did before, where in this case we're dividing instead of multiplying. So here we would have subtraction instead of addition, which is x to the first power, which is just understood as x. Now, keep this in mind. You could spread this out as well, and remember that x over x, or anything over itself, is equal to 1. So if we had x times x, which is the same thing as x to the third, and x times x, which is x squared, each of these values would be equal to 1, so that they would technically cancel each other out, and in doing so we would just be remaining with a singular x, similar to what we had up there. So very important that you recognize this. Now, here's a place where a lot of students have a little bit of trouble. If we were to take a problem like this and say x squared over x to the 4th, and we use the property that helps us use subtraction, so the quotient of powers property allows us to use subtraction, and we ended up 2 minus 4, we get x is to the negative 2 power. And if we recall from just the property before, we actually need to change this. Of course, if you chose to go the extended route where you expanded the actual x values, these would cancel out and those would cancel out, leaving you which looks like nothing up here, but keep in mind x over x is 1, x over x is 1, so you're technically left with a 1 up top and an x squared on bottom. So this is a situation where students can sometimes get confused, so just be sure that you understand that model. Now, the way that I like to look at it is this: whichever value is bigger is where the leftover variables are going to be. So if you look at the example at the top, the value of x that is bigger, the exponent that's bigger, is on top. So technically this was x to the first over 1, because 1 was left on the bottom, and so the extra variable is left on top. Now it's an understood one, so we don't actually write that in the final answer. However, in the bottom, the larger value is in the denominator, and so the extra values of x, or the extra x variables, are left in the denominator. However, the 1 is in the numerator is important to write. So that's maybe a quick and easy shortcut or a way for you to remember that particular property. And then lastly, the power of a quotient property just shows that the power can go to everything inside of the parentheses, whether it's a fraction or not. So